The third type of hierarchical trees diagram is tree map diagram. Okay, so this slide explains the characteristics of tree map diagram. So tree map diagram is an alternative method for displaying hierarchical structure of tree diagrams. It can be broken down to show 2 to 3 different hierarchical layers of data, which will be difficult with other types of chart. Tree maps do not only show value hierarchy by splitting the whole area into smaller rectangle pieces, but also show the value relations by obtaining rectangles of different sizes within each split category. This tree map diagram represents distribution of car brands. Okay, so it is displayed by different color and proximity. Each color represents one brand. And it displays the quantities for each category via the area size. So the bigger the area size, so we understand that the quantity is higher as compared to the smaller size of rectangle. So each category is assigned a rectangle area with their subcategory rectangles nested inside of it. For example, in Ford, okay, so we have Ford Escape, Ford Explorer, Ford Focus, and so on. Tree map diagrams is easy to spot patterns, such as which items are a store's bestseller. So can you guess, okay, which brand is the bestseller car in this diagram? Okay, I would say Ford, Toyota, and Chevrolet are the 3 top brands, okay, or the 3 top most selling brand in this store. Okay, and we can identify from each brand which model, okay, it is the most popular. So in this example, you can see that the size distribution of all car brands is according to their weight in the market, and each separate car brand category split into the matching car series subcategories. Let's learn the tree map anatomy. The founder of this tree map diagram is Ben Schneiderman. So he developed tree maps as a way to visualize a vast file directory on a computer without taking up too much space on the screen. So this makes tree map a more compact and space-efficient option for displaying hierarchies that gives a quick overview of the structure. Tree maps are also great at comparing the proportions between categories via their area size. The way rectangles are divided and ordered into subrectangle is dependent on the tiling algorithm used, or we call it as the squarified algorithm, which is the one commonly used algorithm which keeps each rectangle as square as possible. So in this anatomy of tree map diagram, we can see that the top one is the basic tree diagram, and at the bottom is a tree map diagram. Okay, so A is the parent. Okay, so the overall rectangle or box is A. So A consists of node B until H. Okay, so you don't look A as this very slim rectangle, but A is actually representing the whole square. Okay, so A has 1, 2, 3, 4, 5, 6, 7. 7 nodes or 7 children, okay, but at multiple level of representation. Okay, so how do we represent the size, okay, of each square? So of course, the area of the size is displayed in proportion to the quantity, okay, and to the other quantity within the same parent category in a part to whole relationship. Okay, for example, A has child B and C. Okay, so total A is 200. So B is part of A. Okay, B consists of 80 units, whereas C is 120 units. So we can see that B area is smaller as compared to C. Okay, so this is C and this is B. B has 2 nodes or 2 children, D and E. Between D and E is bigger than D. Okay, because we can see the amount here is higher than D. Okay, so that's why E is bigger than D. Okay. And for C, it has 3 children. So within that 120 units or space area, so it has to divide within by 3. Okay, 3 square or 3 rectangle. Okay, the smallest one is F with only 20 units. Okay, and then H is the biggest one or the largest one with 60 units. Okay, and then G is 40 units. Okay, so the area size of the parent category is the total of its subcategories. A equal to 200, B equal to 80, and C equal to 120. So if no quantity is assigned to a subcategory, then its area is divided equally amongst the other subcategories within its parent category. Okay, so mean that if there is no quantity mentioned, the algorithm, okay, will divide the area equally, okay, amongst other subcategory within the same parent. The third type of hierarchical trees diagram is circle packing. Circle packing is also known as circular tree map. So this slide explains the characteristics of circle packing. It works by the same logic as the tree map hierarchical data visualization chart, but it uses circles instead of rectangles. Circle packing displays a whole area with a single circle, and the biggest circles represents the main categories or the parent. Each smaller circle inside the bigger circle represents a value that in proportion to the parent and the entire circle accordingly. This type of visualization, okay, is best suited to display a large area with multiple elements that makes it up, and their relations to the whole and to each other. For example, okay, this outer circle is the parent, and it has how many children? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if we go deeper, if we zoom in, so this individual circle is the parent to the children or the nodes inside this circle. Okay, so this kind of circular tree map, okay, is best suited to display a large area with multiple elements that makes it up, okay, and their relations to the whole and to each other. Okay, so now we come to the circle packing anatomy. Okay, so the containment within each circle represents a level in the hierarchy. So each branch of the tree, okay, is represented as a circle. And then its sub-branches are represented as circles inside of it. Okay, for example, this tree diagram, okay, we can see that A is the parent, okay, and A has node B and C. So we have this. So we have two bigger circle inside it, that is circle B and circle C. And B has two children, D and E, whereas C has three children, F, G, and H. And again, the area of each circle can also be used to represent an additional arbitrary value, such as quantity or file size. Color may also be used to assign categories or to represent another variables via different sheets. As beautiful as circle packing appears, the downside of it is that it is not as space efficient as tree map, as there is a lot of empty space within the circle. So this is empty space, okay, empty space, and we cannot maximize, okay, the area as compared to the tree map. So despite this, circle packing is actually reveals hierarchical structure better than a tree map. Do you agree with that? So you might want to compare between this representation, which one is better to represent the structure. And the fourth type of the hierarchical tree diagrams is radial tree. Radial tree is also a hierarchical way of displaying a tree structure data, but in a radially way, okay, in a way that expands outwards. This visualization structure is an effective way of displaying data in terms of space used because the root is displayed at the center. And the nodes of different levels, okay, for example, this one we have the first level, second level, third level, and fourth level. So it's first, second, third, and fourth. Okay, so the nodes of different levels are placed in circles of different radii. Okay, so radii is the radius, okay, the plural word of radius. So for example, at level 1, okay, the radius, for example, would be maybe 2 centimeters. And at level 2, the radius from the center could be 4 centimeters. And the third level could be 6 centimeters from the central node. And the outer level, probably 8 centimeters from the central node. Okay, so that's why this type of structure is more effective on this in terms of the space use. Okay, and we can place more nodes at deeper levels. So deeper levels mean as we go outwards from the center. So this example, the first one is a representation of radial tree diagram for classes in a software package hierarchy. Okay, and then in this one is an organization chart that emphasizes a central authority in the year 1924. Okay, so probably in the millennium, okay, the representation of organizational chart would be different. Okay, so that's this is how, okay, we interpret, okay, the radial tree representation of hierarchical trees diagram. You can go to the website, the link here, to see the detailed diagram of both examples.